Hello viewers, welcome you all for analysis of continuous beam using Untitled Chapter. Go to File, click on New Model. In this Model Initialization tab, we will set the units for the drawing. Three ways you can set the units for your drawing. One thing is you can use some of the units which has already been saved in the software. Otherwise, you can use some of the units by importing some model which has already been analyzed. And third way, you can use the units of your own. I will go with use built-in settings where you can set my own units for the drawing. I will be selecting metric as my display unit, Indian as steel section database, IS 800 2007 as steel design code, and IS 456 2000 as concrete design code. Click OK to escape from the dialog box. In this new model quick templates, we will be entering the data of grid system and story dimension. Here I am interested only to create a one story which is of 3-meter height. And coming to the beam, I require 3 grid lines along x direction. Therefore, the number of grid lines I want to create along the x direction is 3. As many number of grid lines if you want to create along the y direction, you can create it. I will be creating only 2 grid lines along y direction. Then coming to spacing between the grids are different. If it is same, we can go for uniform grid spacing. If it is different, we can go for custom grid spacing. I will go for custom grid spacing because the spacing between the grid lines is different. I will click on edit grid data. Here there are two ways you can set the spacing between the grid lines, one by coordinate system, another one by spacing system. In coordinate system, grid A will be taken as a reference. With that reference, other two grids will be created. Now grid A is 0, 0. Then for grid B, the distance between A to B is of 4 meter. I will enter that value in the blocks. Then distance between A grid to C grid is 7 meter. I will enter that value in this box. Click OK. Select grid only option. Then click OK to escape from the dialog box. Here what we are saying is this is a plan view and this one is a plan view and this one is a 3D view. If you want 3D view, you can keep it, otherwise you can delete that view. Next thing is to define the material and section properties. Go to define. Under material properties, we have to define two materials. One is concrete, another one is rebar for reinforcement. Click on add new material. In this, we have to select Indian from the drop-down list for region. Then we will define the concrete material, which is of Indian standard of grade M20. Click OK. Again click OK to escape from the dialog box. One material we have created it is of M20, it is concrete, and another material we have to define it is of rebar. Again go to add new property. In this you have to select rebar from the drop down list instead of concrete, which is of HYSD 415 grade. Click OK. Again click OK to escape from the dialog box. Click OK to define the two materials. The next one is to define the section properties. Again go to define. Under section properties we have to select frame section because we are analyzing the beam. We have to define the beam property. You can select any one of the property from the list. Go for modify or show property. Here I am defining the beam as B230 by 400, which is of concrete material of grade M20. Beam which is of 400 mm deep, 230 mm wide. Click on modify or show rebar. Here we are designing it as a beam and the reinforcement is of rebar HYSD 415 grade. We have to specify the cover of both top and bottom bars. Click OK. Click OK to escape from the dialog box. Again click OK to escape from the dialog box. Here we have to draw the beams. There are two ways you can draw the beams by using these two options. We'll go with the second option, that is quick draw. In this dialog box, we have to select the property of the beam which I have defined earlier. I will be selecting it as B230 by 400. Now place the cursor on the line and click it in order to create a beam. Once you have created beam, you can close the dialog box. You can press on select object to come out of the option. After this, you have to go for the elevation view. For that, go to view, set elevation view. Here I have drawn the beam for the elevation 2. Select that from the dialog box. Click OK. After selecting this, I have to assign the supports for the joints. We select joint A, go to assign, go to joints, then restrain. At joint A we have a fixed support. You select that fixed support, click OK to assign the support to the joint. You select other two joints which is of fixed support. For that, again go to assign, go to joint, restrain. You select hinge, click OK to assign the support to the joints. After assigning supports, we have to assign the loads. For that, you select the beam, go to assign frame loads distributed. We are assigning the load as a live load. For portion AB, it is an UDL of magnitude 60 kN per meter. We have to enter that value in this box. Click OK to assign the load on the beam portion. Again, we select another portion, it is BC. Go to assign, go to frame loads. There is a point load which is of 100 kN, is acting at the center of the span. We select live load from the drop down list. I will be selecting absolute distance from end I. For distance, I will be entering the value as 1.5 in order to add the load at the center. Then load is of 100 kN. Click OK to assign the load on the beam. After assigning the load, we have to run the analysis. First, we have to check the model for the errors by selecting all these parameters. Click OK. No warning messages are generated, so that we can run the analysis. In order to run the analysis, you can click this option. We have to save the model. Once you save the model, analysis will be run. This is the elastic curve of the beam due to the applied load. In order to obtain the shear force and bending moment, you can go for this option, that is display frame loads or moments. Here we have to select the live load from the drop down list. First, I will be selecting the shear force 22 along with the fill diagram to show values. Click OK. This is the shear force for the beam for the applied load. You can select the beam. If you right click on it, you can get the maximum minimum shear force along with the point of contact flexure. If you want to obtain the moments, do the same option, that is display frame loads or moments. You click on it, you have to select live load and moment 33. Click OK now to obtain the moment for the beam for the applied loading. Thank you for watching this video.